Good morning or good afternoon. I hope that you're having a great break so far. As we get started on this mid-chapter review, these are all things that you've seen before, so you don't have to watch this video, but if you want to reference it for information, I'm going to be going over examples on page for the problems on page 321, number 1 through 26. Don't do these, okay? Don't do 7 through 9. We haven't discussed how to do that yet. Okay, so 1 through 26 all. I'm not going over all the word problems, but this is the basic skill set that you need in order to answer all the questions. Okay, so the first one you're going to do is finding a rate of change using a table. Here are the steps for doing it right here. Okay, so the first thing is you're going to find the change in y or the output. How do you find the change in y? You take the second point and subtract the first point. In this case, I get 260. I can repeat between 780 and subtract 520. I also get 260. And you can see that this is a constant of 260. So that's my change in y. So I have 260 all over, right? Because I'm going to divide here. You see change in y over change in x. In this case, it's actually the change in distance over the change in time, because distance is my y value and time is my x value. And so this one's kind of easy. It's always jumping by 1, so my change in x is 1. So I have 260, and then the last thing is don't forget your units. So what we're looking at is the units. Distance was my numerator, so I have feet per, and then minutes was my denominator, per minute. So this is saying 260 feet per minute, and that's my rate of change. Okay? Next type of problem that you will see is find the slope of a line that passes through each pair of points. Okay, so all we're doing is we're going to be using the slope formula. This is the slope formula right here. You'll need to memorize it. This is the same thing as change in y over change in x though. Remember on our table we subtracted the second point or the first point from the second point, and that's what we're doing here. You really doesn't matter. You're just identifying it x1 and y1, x2 and y2. But no, x1 and y1 are always together, and x2 and y2 are always together. I've identified this first point as my x1, y1, and this one is my x2, y2. You can do the other as well. Just makes it easier once you've identified to separate them. If you hadn't identified it the other way, you would write this as x2, y2 underneath, so that way you would know. Okay, I'm not doing that for this one. Okay, so I then plug it into my equation. So the first one was y2. My y2 is -2, and I substituted it in. Next, minus my y1. My y1 is 0. I've substituted it in. x2 is 3, subtraction, and then my x1 is -1. Remember that subtracting a negative is like adding a positive. This is also adding a negative, but 0 doesn't have a positive or negative, so we just get -2, and then 3 plus 1 is 4. But I always have to simplify. Both of these can be divided by 2, which gives me -1/2, and this is my slope, or f. Alright, next type of problem is writing an equation in slope-intercept form of each line. Okay, so it's actually going to give you a graph. And here I have a graph. And I've gone ahead and drawn a line. And I went ahead and identified these points because they were nice and easy to see on my line. So the first thing is we do is find the rise over the run. So I'm going from 0 up to 4, so my rise is 4. Then my run, I'm going from -2 to 0, so my run is 2. So remember, it's rise over run, which we then simplify to 2. So now I have my slope. This is my M. The next thing I need is my intercept, my B. Intercept is where it intercepts the y-axis, which I've already labeled here. So the intercept is this number right here, the second point, or where does it cross? And so my intercept is 4. So now I can write an equation of the line, because slope-intercept form is y equals mx plus b. Y does not get changed because this is for all values of y. M I identified as 2. X stays x because it's for all values of x. And then my intercept was 4. And this is my equation of the line. We can have it in, so I'm just going to make some examples. We're going to use the example we had in the last one. So y equals 2x plus 4. Okay, so I'm using the process in reverse. I'm given this graph. So the first thing I'm going to do is look here at the intercept, and then that's where it intercepts the x-axis. Let me change my color so you guys can see a little bit better. Okay, so right here where it intersects the x-axis, and then it says to use the slope, rise over run to create additional points. Remember, when it's a whole number, this is like rise over run. So I'm going to rise 1, 2, run 1, make a point. Rise 1, 2, run 1, and then connect your dots and make it a line. All right, let's make an example right here. I have this example right here that's in point slope form. So it says find the point. This is my x1. This is my y1. So I can then have the point 5, 2. Remember, if this is positive, then it's indicating that you need to change the sign. So now I have a point 5, 2. And that's where I'm going to graph first. 5, remember x is always over. 5 up 2, and this is my starting point. In this case, my slope right here is 3. So we can write that as 3 over 1, and we use the same process. 1, 2, 3, 1, 1, 2, 3, 1, and we connect our points. Being mindful, if your slope is negative, that it will always face the other direction. I'm going to go ahead and give you one more example in that point slope form. So let's say we have y plus 2 equals negative 1/2 x minus 3. Okay, so the first thing we're going to do is we're going to identify our point. So our point is 3, negative 2, because this is addition right here. So I'm going to go ahead and graph that point, 3, negative 2. Then the next thing is negative, this is a negative slope, so we can think of it as rise over run is down 1 over 2, or you can think of it as rise 1, left 2, connect your points, and we've now graphed it. Okay, next type of problem you're going to see is write the equation of the line in point slope form. So we have point slope form right here. This is simply a substitution. M is M. This is x1, comma y1. So we just substituted it. Remember, y stays y for all values. Oops, that should not be an equals. That should be a subtraction. Okay, so y minus my y1, which in this case is negative 3, is equal to m. It's given to me as negative 1/4. X does not change. This is for all values of x, but this is a specific x1, So in this case, 2. So now we can clean it up by right here, we see that this is minus a negative, so we go ahead and change that to addition. And this is my answer. Okay, let's keep on going. All right, so now we're gonna write the equation of a line, but it gives us 2 points. It doesn't specify whether to use slope intercept or point slope. So if it doesn't specify, use point slope. It is the easiest of the 2. So the first thing we need to do is we need to find our slope. So do you guys remember the slope formula? M is equal to y2 minus y1 all over x2 minus x1. I'm going to go ahead and identify my points. Either way, it doesn't matter. I'm going to go ahead and identify this as my x1, y1, and this is my x2, y2, just to change it up a little bit so you can see it doesn't matter which one. But you just plug them in. So y2 right here is 4 minus my y1 right here, negative 6, all over my x2 right here minus my x1, negative 3. Because I have subtracting a negative, this changes to addition, and I get 10 over 5, which is equal to 2. All right, so now I have my slope, and then I'm going to use point slope form. Point slope form is y minus y1 is equal to m times x minus x1. Okay, so I can go ahead and use my y1 and x1 points. Y minus my y1 was negative 6. My slope I just found right here, right? This is my m right here, so I'm going to plug it in 2. X doesn't change, and my x1, negative 3. Okay, so this still works if you had identified your points differently. I'm going to go ahead and show you the exact same answer if we identify it differently. So I'm going to identify this as x1, y1, x2, y2, and quickly go through the same process. So remember, the first thing is finding slope, which is y2 minus y1 all over x2 minus x1. My y2 in this case is negative 2 minus y1 minus 4, negative 3 minus 2. This is like adding a negative. I get negative 10 divided by negative 5. A negative divided by a negative is positive, so I get positive 2. Same slope. Y minus my y1 now is 4 is equal to 2 times x minus 2. These are both valid answers. Okay, and that's it for the review. Have a happy Thanksgiving and enjoy your break.